This is Lucy Sullivan interviewing Pete Seaba on Tuesday, May 22nd, 2012. Pete, where and when did you receive your degree, and where do you currently work?
I received my Bachelor of Science in Electrical Engineering from the College of Engineering, University of Iowa, January of 1966. Received my Master's in Electrical Engineering from Graduate School in August of 1967. I retired last August from the University of Iowa and had put in two 19-and-a-half-year stints with breaks working for the Department of Defense and Industry.
What drew you to EEG and diagnostics?
As I thought back, the first thing I ran across was Dr. Bickford's demonstration, a 3D movie of a spike at the Mayo Clinic. I think he was working there in 1965, and I was there on an engineering conference. Then I co-authored a paper in my senior year, Hybrid Computer Simulation of Mammalian Cardiovascular System. It was an easy project and got a lot of attention, requests. But what finally brought me into the lab was a psychology experiment. Engineers tend to wait to the last minute to fill in their research hours. I did too. So I went over, took a 4-hour credit experiment in Psych Hospital, and as I got there, the person said, well, the equipment isn't working, we'll give you an hour credit. I said, give me 4 hours credit and I'll get it working for you. He agreed, and we had it going in no time. I got a call from his lab offering me a job the next week, so I was started then as a half-time engineer, July 1st, 1966. Was also a half-time teaching assistant and was a senior in electrical engineering.
Was EEG a popular specialty when you started your career?
No, the second conference was just held in 1967 at that point. The field was very young and not well known enough to be popular.
Who were your early mentors?
The primary one was John Arnott, who was a PhD in psychology. He encouraged me to write a paper and got it back. It was full of red marks, edited all over. Later, I was told his father, Thomas Arnott, was a general editor of Webster's New International Dictionary, so I got his editing from him. The second person was Dale McAdams, head of research in our group.
What were your earliest career influences?
I think money. I was well paid as an engineer in the research and EEG group.
If you had not become an engineer, what would you like to have done?
Probably teaching and engineering.
Why do you think this field took off when and how it did?
I think the field took off when the schools were in place, maybe in the early 1970s. Then there was a renewed interest when evoked potentials came into removing their clinical usefulness, the brainstem auditory and pattern reversal visual. Another boost came when sleep studies came into use, and followed by long-term monitoring. Most recently, the OR monitoring subgroup seems to have sparked interest.
What equipment have you worked on, and what were the main limitations of it?
The ones we used in the lab were usually the graphs. We started with Model 3. We did have a Model 4, Model 6s, and Model 8s. So graphs was a primary one. They did lack all of them lacked portability and a thing called buffered inputs. Buffered inputs allowed you to use a common reference and not upset the balance of the differential amplifier.
What other equipment have you worked on over the years, and what are the pros and cons of them?
Start with maybe the neon code was the next most popular. We had some Midcraft. Offner T, and some other startup companies tried it. Jim Grishnek was one. The problems for most of them is support. A lot of companies were geared to sell equipment, but not to support the operation. So that would have been the cons of it. But pros, you did get a response when you called in, and they delivered and set up the equipment.
What memories do you have of when you started out?
Well, there was a lot of memories. I helped teach the first program at Iowa in 1966. There's been many since. I think six out there, most of the comical things, like one of our students had a party they had for the incoming students, managed to throw a frisbee up on John Knott's roof with a newly screened-in porch. Put his foot through the screen onto one of the cross members and continued to put his foot in the screen and climbed up the side of the wall and got his frisbee. There are many other amazing stories, and the most interesting thing is that we had hands-on electronics at the beginning. People soldered together a little tube amplifier, stage by stage. Recently, I've tried that with our new students, and we'll see how it works out. Except they use a little breadboard, and you plug your stuff into it and watch it work.
What are the main ways in which the field has changed over your career?
EEG is the bandwidth and requirements of that are pretty much the same. However, making the machine more portable, being able to reformat and the storage and display media, we don't get ink on ourselves anymore.
How has scientific knowledge changed the field, and what do you think were the big breakthroughs?
Well, epilepsy is still a single confirmatory test for epilepsy. Portable recorders are becoming more reliable, so we can also use it to determine treatment, get a better hold on the main problem in epilepsy.
What are the 2 to 3 big issues in EEG that people are working on to solve today?
Trying to increase the accuracy, get the activity around the electrode instead of the spread that occurs across the head. Different dimensional views of the data, converting electrical maps across the scalp into magnetic maps. Depth-wise, hoping to mathematically imitate what magnetoencephalography